Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 17 in our incredible new tutorial series where you're going to learn Fusion 360 or you're going to die trying. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That is straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. You guys that are not helping out yet, take a look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what we're going to do is we're going to dig a little bit deeper into the topic of design rules. And design rules is one of the things that in the world of 3D printing and in the world of home hobbyists and makers, we're not doing a very good job. We're just kind of winging it, and most of us don't really have a very good quantitative understanding of what the printing capability of our printer is. Now, last week I kind of introduced this topic a little bit in that we got our vernier calipers, we learned how to use them, and we printed these two very simple structures, a cube and a cylinder. And with these simple structures, we sort of saw, at least for my printer, that along the x-axis and along the y-axis, I had a printing precision of about 0.05 millimeters. Not bad at all. And then in the z-axis, I had a precision of about 0.1 millimeters, not quite as good, but what it seems like is I'm squished down a little bit in Z. Perhaps that first layer is getting squished down a little bit. Not quite the precision in Z that I have in X and Y. Then on this cylindrical type structure, I found the same thing, about 1/10 of a millimeter error in the Z direction. And then also we learned that I could not print a circle as precisely as I could print a square. The outside diameter of the circle was about 0.25 millimeters smaller than expected, as was the inside diameter a little bit smaller than expected. So we got a first initial look at what our printer precision, what print precision our printer is capable of with these two simple structures. But today what we're going to do is we're going to go in and more formally design and print a design rule checker that will enable us to more formally understand what the print capabilities of our printer are. And there's really four primary things that I want to do with this next level of design rule checker. The first thing is, how small of a line can I print? How thin of a line can I print? So can I print 1 millimeter? Well, I would hope so, but I'm going to go from 1, 0.9, 0.8, 0.7, 0.6 down to 0.1 and see how small of a line, how narrow of a line can we print before the line isn't there. Now, the other design rule that I want to determine is how small of a slot can I cut? How small of a slot can I have in width? In other words, think if I have two columns, how small can I make, how narrow can I make the gap between those two columns before it bridges and just becomes one column? So the first design rule, we want to determine how narrow of a line can I print. The second design rule we want to determine is how narrow of a slot or a gap can I print. The third thing we want to determine is, it kind of gets back to that work we were doing with gears riding on axles. What is the tolerance between the gear hole diameter and the axle outer diameter to get a snug but yet unimpeded smooth spinning? What tolerance should we put in? We're going to do a design, we're going to determine that design rule. And then the fourth design rule we're going to determine is if I have two posts with nothing between them, can I print between those two posts? Well, if they're very, very close together, it would just print over that little air gap, no problem. But as that gap gets larger and larger, you're going to reach the point that it's going to sag and you're not going to be able to print. So what is the largest gap of air that I can print over? So that's what we're going to do, and we're just going to jump in and start designing this. And so I will need you to go to Fusion 360. I will need you to create a new sketch, and we're going to sketch on the XY plane, and we are just going to jump in and we're going to start designing this. We're going to start by making a variety of different size holes. We're going to have a pin. The pin is going to be 15 millimeters in diameter, and then we're going to have different size holes going from smaller than 15 to bigger than 15. And then after we print it, we will understand physically with these objects in our hand how the different tolerances, how the different sizes will behave. So we're going to come in and we are going to build a rectangular base. That rectangular base is going to be 136 millimeters tab by 45 millimeters, like that. That is not right. We are going to say 136, like that. And then we're going to tab and do 45. So that is our rectangular structure that we are going to design onto. The diameter of the hole is going to be 15. I want the edge of the hole 5 from the side and 5 from the bottom. So if the diameter is 15, half the diameter would be 7.5. Add 5, that would be 12.5. So my construction line needs to come over from the origin 12.5, and then it needs to come up from there 12.5, and that's where the center of my hole should be. I'm going to get these dimensions out of my way, and now we are going to want to create 10 of these holes of different sizes. I can't replicate the hole. I can't create a pattern of the hole because every hole is different. And so what I can do is get my position, my center point positions as is something that I make a pattern out of. So with that, I'm going to say create a rectangular pattern out of what? Out of this point. And then what I want to do is I want to do a spacing, and in the X direction I want to have 5, and then I want to have them 20 apart. Why 20? Because I have the circular diameter of 15, okay, and then I want 5 between them, so that would be 20. So that will be like that. And then in the Y direction I want to have 2 rows, and similarly I want them 20 apart. And so now at least I've got a place to put my circles, and nominal is going to be 15, and we'll just start that out here. So we'll start here with a circle, and it is going to be our nominal of 15, like that. And then our next one is going to be smaller, 14.9. And then here is 14.8, 14.7, and 14.6. Now up here will be 15.1, 15.2, 15.3, 15.4, and 15.5. So we've got nominal 15, and you can see that we're going from clearly too small to clearly too big, and then we've got a range in between there. Hope that makes sense. Now, Even though I had to individually draw those circles, it went much quicker because at least I had the point that I could draw on. And at the end of all this, we are still fully constrained. Now, out here in this region, I want to build those bridging structures. All right. So I want to build posts, and I want the gap between those posts to be greater and greater. And then I want to see if I can bridge, if I can span that bridge by printing over air for some distance. So we're going to need to come in and here build our rectangles, or our squares for our columns. So I'll need to get a good space for that. And so I will need to come over, let's see, I'm going to come over, I need to come over 35. So I'll come to the corner and I will come over 35 with a construction line, and that was not a construction line. Let's try that again. So I will come over with a construction line 35. And then I'm going to come down. I'm going to come down. Each rectangle is going to be 4, and then I'm going to want to be 3 from the edge. And so half of 4 would be 2 plus 3 would be 5. And so I'm going to come down here with a construction line 5 millimeters. And that will be where I will build from. Okay, and this is a little too close. I missed that. That should be 34 over, like that. Okay, now I can come in and I'm going to replicate this. I'm going to replicate this point down. So I'm going to create. No, I'm going to build my rectangle first. And so I'm going to come in. I'm going to build my rectangular column, and it is going to be a center point rectangle, and I'm going to want it 4 tab 4 by 4, like that. Now this whole thing I'm going to create a pattern from. I'm going to create a pattern from that. It's going to be a rectangular pattern, and I am going to want 1, 2, 3, 4, 5, 6. So going in the Y direction, I'm going to want 6, and then I'm going to want them how far apart? I'm going to want them 1, 2, 3, 4. I'm going to want them 7 millimeters apart. But it's going to, if I put 7, they're going to replicate up, and I want them to replicate down. So I'm going to put -7 millimeters, like that, okay? And now you can see that I have that evenly spaced, and that 34 is even a little bit too big. So I need to go back and I need to make this to here needs to be 32. So basically you want the center of this column of squares to be 32 from the edge, and then that is nicely spaced. All right, now what I need is I need to build the other column, and the easiest way for me to do that is to build a construction rectangle. So I'm going to get my rectangle, and I'm going to come from this upper left corner, and I'm going to make this one 31 tab 4. Okay, so that one is going to be 31 tab 4. The next one is going to be 4 smaller. So instead of 31, this is going to be 27 tab 4. And then this one is going to be 23 tab 4. And then this one is going to be 19. And then this one is going to be 14. And then this one is going to be 11. Okay, Okay, so do you see how I'm creating these various sizes of bridge? Well, I don't want it to be a diving board. I want it to be anchored on both sides, so I need to build the corresponding rectangle out here, or the corresponding square. So I just start here. These will not be construction squares because these are going to be columns. So this is going to be 4 tab 4 right there. And then my next one is going to be here. 4 tab 4. 4 tab 4. 4 tab 4. 4 tab 4. And my last one, 4 tab 4. So let's see. This last one was 11, but then we took off 2 for 9 and 2 for 7. And so let's see. No, this would be 11 minus 8. So this gap here would be 3. So we're printing over air for 3 millimeters up to 19 millimeters up here. And so we'll see, can we print over air for 19 millimeters? This will answer the question. Now you'll see that I need the rectangle to build that top bridge, but I don't want that rectangle in this sketch. I'll do that later after we extrude the rest of the things. We are fully constrained, okay? And that looks really good. Now what we need to do is we need to come in and do the lines. We're going to build lines of different dimensions starting at 2 millimeters and going down to 0.1 millimeters. And so let's go ahead and do that. And so what we're going to do is we're going to build another base. We'll start at the origin, and we are going to come down 25, and then we are going to go over, that was let's do 136 in the first dimension, and then tab 25, like that. All right. So this is the rectangular area we're building in. I'm going to get these dimensions out of the way. Okay, now what we're going to do is we are going to build rectangular slots that are 5 millimeters by 15 millimeters, and as we go across, the slots are going to get closer and closer together. And so the first slot I'm going to want my first slot 5 millimeters from the edge. So I'm going to make myself a construction line. I'll come 5 from the left, 5 millimeters, and then I'm going to go 5 millimeters up, 5 millimeters, and now I've got a point to build on, and I'm going to get these dimensions out of the way, and that is going to be the point for me to build on. So I'm going to get my rectangle, and this is where it's going to get tedious. But I've got to individually draw each rectangle because they're going to be at different spaces, so I can't just replicate. So I'm going to create not a construction rectangle, but just a good old-fashioned rectangle. I'm going to come here, and I'm going to come over 5, tab 15. So 5, tab 15. Now, the next rectangle I want over by 2 millimeters, so I'm going to create a construction line. It's going to be 2. Now I'm going to create another rectangle, and it will be 5, tab 15. Construction line. This time I want the line to be 1.9. Now rectangle, 5, tab 15. Okay, so what I want you to see is when I extrude this, I'm going to have a line that is 2 millimeters. And then here I'm going to have a line that's 1.9 millimeters. So I've just got to replicate this pattern one at a time all the way down to 0.1 millimeters. So we're going to come in, construction line, and I am sorry this is tedious. 1.8. our rectangle. 5 tab 15. Construction line. 1.7 rectangle. 5 tab 15. Construction line. 1.6 rectangle. 5 tab 15. Construction line. 1.5 rectangle. 5 tab 15. Slowly but surely. .4 rectangle. 5 tab 15. 1.3 5 tab 15. 1.2 5 tab 15. 1.1 5 tab 15. Construction line 1. 5 tab 15. We're halfway there. 0.9. 5 tab 15. 0.8. 5 tab 15. The good news is for the spaces, we don't have to do this. We can just reuse this one. So once we're done with this, we're going to be in good shape. Okay. Construction line 0.7. I don't think that was a construction line. I'll fix it. Rectangle 5 tab 15. Construction line 0.6. Rectangle 5 tab 15. Construction line 0.4. rectangle, 5 tab 15. We're so close. Construction line, 0.3. Five tab 15. Did I mistype that one? I don't think I got it. Let me just back off of that one. For some reason I didn't do that one right. So let's try that one again. Here, 5 tab 15. Okay, that's happy. Almost there, guys. This one's going to be 0.2. Rectangle, 5 tab 15. And finally, the last one is going to be 0.1. 0.1. And now we will come there with a rectangle. 5 tab 15, like that. All right. So do you see what's going to happen? That we're going to start, and when we extrude this, we'll go 2, 1, 9, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, as you go on across with smaller and smaller gaps, or smaller and smaller lines that we're going to be getting here. Now, the nice thing is we're trying to do the same thing. Instead of with lines with spaces, we can just use this structure again. We can just use this structure again. We don't have to go in and make it again. But for some reason, I feel like I am missing a line in there somewhere. So that's 2, 9, 18, 17, 16. Yeah, I missed one. Did you guys see that? So I need to come in and fix this. This should be 5.5. And this should be 0.4. This will be 0.3. This will be 0.2, and then we'll need to add one more. So we'll come out with a construction line at 0.1, a rectangle of 5 tab 15, and now, okay, yeah, now that looks right. So we have all of those. So the reason I noticed that my sketch wasn't fully constrained, and I had one thing in here that had not gotten dimensioned, and I just fixed that, because at this point everything should be fully constrained and is fully constrained. Okay, guys, that is probably the most tedious 15 minutes of YouTube history there, but we've got that done, and now things are going to get a lot easier, because what we're going to do is we're going to create a mirror line, and we're going to mirror all of this up here, and we'll get spaces instead of lines on the top by just extruding differently, and so we don't have to redraw all of this. But we will make a construction line in the middle of this, so we look for the little triangle to pop up, and that will be the center point over here, get the little triangle. That will be the center point. Now we are going to select all of this. And now what we want to do is we want to create a mirror. And we have 206 items selected. And we want to select now mirror line. We want to mirror about this. And then that will be okay. All right, we're fully constrained. This is going to be our various size lines. This is going to be our various size spaces. These are our various size holes. And now all we need to do is come over and make our pin, and then we'll be ready to start extruding. I am happy to announce that the worst is behind you. The rest of this is going to be pretty easy. So we're going to come here and we're going to come out with another construction line, and we'll come to the center here and we're going to come out with a construction line 150 like that. All right. Now we're going to build a circle, which is going to be our nominal circle, which is going to have 15. It'll be our pin to test these holes out. So it's got a diameter of 15. And now we want to build a base around it. So I'm going to make a center point rectangle. You see how I'm getting center point up here. And then that is going to be 25 tab 25. And now I've got a base. I've got a base that'll have a pin coming out of it. I think that for right now we're ready to extrude. Just remember, we're going to have to come and build these top bridging structures, but we'll do that in a different sketch. So we can finish this sketch fully constrained. That's good news. And we are ready to extrude. And so I'm going to start with my little structure over here. And so I'm going to take this and I am going to extrude it. I'm going to extrude it 15. And then I want a pin coming out of that. I'm going to turn my sketch back on, and I want this pin coming out to a height of 55. Okay. So this will be the pin that we are poking down in these holes to see how it is going to behave. Now, all of this, let me hit extrude. These are going to be my lines. So I want to extrude all of this, and I want to extrude all of this, and then I want to extrude all of these. And it'll make sense as this thing comes along. But all of these are going to go all the way up. These are the things that I'm printing. And so those, I think, are going to come up to 30. So I'm going to extrude those to 30. Like that. Okay, so already what I want you to see is, I'll turn the sketch off. Do you see here we're printing columns closer and closer and closer together? So how small of a gap can we get before the two columns are bridging together? Does that make sense? All right. And then here on this part, how small of a line can we print before the line disappears? Now I need to go ahead and I need to extrude the base. Even those, all these need to sit on a base. And so what I need to do is I just need to give them a base to sit on. So that will be this, this, all the holes, and then all these little slots, just so that they don't have holes all the way through. And these are just going to extrude by 5. Extrude by 5. Okay. And I want to make sure, yeah, I've just got 2 bodies, and that's what I want. This is a body and this is a body. So everything's coming together as one body. I have my lines completely defined, my spaces completely defined, my holes completely defined in my pin. Now I need to do these columns for my bridging structures. And so now I'm going to come in, I'm going to do another extrude, and I'm going to get this if I got to turn my sketch back on, I'm going to get that, 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 that. Get all of these, and then we are going to need to extrude those 35. So that's 5 taller than what the underlying layer was. So that'll be 35. And now we should see them just pop up over the top there. Yeah, so that looks good. I think that's good. Let me just check one dimension here. Yeah, that's going to be right. Now what I need to do is I need to build the bridge between the posts. And so I need to do another sketch to do that. So I'm going to say create a sketch, and then I want the sketch on the top of this post like that. Now I should be able to just build the bridge with a rectangle, and it should snap to the underlying layers but be on this layer like that. Okay, it stayed fully constrained, so I'm sketching up here at the top, but it is snapping to the things that are below it, and that is a pretty cool feature to be able to do that. I'm staying fully constrained because I'm snapping to those rectangles that are down below. Okay, so I've got all my rectangles. I'm going to finish the sketch, and there are all the rectangles. Now I'm going to want to extrude, and I'm going to want to extrude this, and this, and this, and this, and this, and this. And I want those to join to the old body because I don't want a bunch of just floating bodies there. And this I need to get to. For some reason it didn't select that, so I've got that. All of these I'm going to extrude a distance of 5. Okay, and now let's see if we got it. Boom, look at that. So you see I've got these beautiful bridging structures, and we're going to be able to see, whether we can print those long spans over air gap. Well, guys, I appreciate your patience. This has been one of the more tedious designs that we've done, but I just wanted to go ahead and just step you through it step by step. So we've got the lines, we've got the gaps, we've got the bridges, we've got the holes, and we've got the pins. So I think we're ready to print this, and we'll come back after we print it and we'll start doing a little metrology with our calipers. We'll see how things fit, and we'll start defining our next level of design rules. So I'm going to pause the video. I will be back in just a minute. And we're back, and I am happy to announce that we did get a successful print, and we have this thing printed out and ready to take a look at it. And so, guys, I think I am going to go ahead and give you guys your homework assignment, and then I will pick this lesson up in the next video because this video is getting a little bit long already. But here is your homework assignment. Your homework assignment is to get your calipers and to get your design rule checking block that you just printed out, and to start recording a set of design rules. Write down what your design rules are. What is the sheet of paper that you need to have in front of you when you're designing in the future in Fusion 360? So I want you to kind of think about what are the important numbers that you need to determine from this structure that you just printed out. Things that you will look at when you are designing things in the future. So I need you to come up with that list, your design rules for your printer. Now I'm being a little bit vague because I want you to think about this, and then in next week's lesson, what I will do is I will come in next week's lesson and I will show you how I will use the calipers to come up with a preliminary set of design rules for my future designs when I am working on the 3D printer. Again, the theme that we are working on here, and the design theme that we are thinking about, is design for printability, designing with your manufacturing method in mind as you're designing. And so that is what we will be doing next week. Guys, I hope you are having as much fun taking these lessons as I am making them. If you enjoy this video, be sure to give us a thumbs up, leave a comment down below because that will help us with the old YouTube juice, and then share this with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.